All right, so today we're doing Notes 1.1. We're going to talk about, for our learning targets, are going to be to make and interpret bar graphs for categorical data, to identify what makes some graphs of categorical data misleading. We're going to talk about how on two-way tables to calculate marginal and joint relative frequencies, conditional frequencies, and how to use bar graphs to compare distributions of categorical data. And then we'll also talk about how to describe the nature of an association between two categorical variables. Okay? So we have a lot to cover. All right, so just a reminder from yesterday. We have a table here with different provinces, and we're talking about preferred communication. And if you recall, preferred communication is what we mean by categorical variable, because each province has some type of preferred communication, and so they would fall in a grouping, okay? And so that was categorical variable. So those values that you're seeing there, in-person, cell phone, all of that, those are categorical variables. A frequency table shows the number of individuals having each of those values. And so then a relative frequency table shows the proportion or the percent of individuals having each value. So when I say the word relative, what should come to mind is percent. So you might write yourself a note. Relative means percent. Okay? So when we look at example 1A here, it says look at the frequency table and create a relative frequency table. So if I want to make a relative frequency table, I'm really saying is I want to know what percent each category is of the overall, right? So how many do I have total frequency? What's my total frequency? 10, right? If you add those numbers up, 2 plus 1 plus 3 plus 4, you get 10. And so if I'm looking at cell phone users, then 2 out of the 10 would be my relative frequency, right? And so 2 out of 10 is 20%. So if we do that with each of those groupings, 1 out of 10, 3 out of 10, 4 out of 10, then we get each one's relative frequency. Does that make sense? And you can fill that in on your chart on your notes. And so we can use these relative frequencies. Notice a frequency is just a count. Relative frequency is either a proportion or a percent. Usually you write them in percents, though. And we can use those numbers to make a bar graph. So to display the distribution of categorical data, we can either make a bar graph or a pie chart. A bar graph shows each category as a bar, and a pie chart shows each category as a slice of the pie. So here it says, create a relative frequency bar chart and a pie chart using the following table. There is room in your notes to create these graphs. You're going to draw them into your graphs. And so we're going to go and take those same numbers and transform them into, first, a bar chart. Notice on my bar chart, I have on the x-axis it says preferred communication method, so I've labeled that axis. And then on the y-axis, I have a scale that's consistent, meaning it's in the same increments each time and spaced equally. And then just percent as my, to make it clear that I'm looking at percents there. And then if you look, I had 20% that were cell phone users, so my bar goes up to 20%. Now, you could not label those and just put a little bar off to the side that shows purple is cell phone and orange is Facebook. You can also probably get away with abbreviating a little bit, like CP for cell phone. Just don't have the same abbreviations or they won't know which category you're talking about. I'll give you a minute to copy that down. Okay, so that's how we would look at and it doesn't matter what order this is in. If you put Facebook on the left and cell phone on the right, that's not going to matter. As long as your percentages are right. Okay? All right, and then let's look at the pie chart. So we basically use those bars to help us figure out what section of the pie chart we have. So I usually start with the largest percentage. It just helps me kind of, because this is not a strength for me. So I say, okay, 40% isn't quite 50%, so I sort of know where to draw that line. And then, once again, I could put a little scale off to the right that says purple is text messaging, but I could write it in this circle pretty easily. So text messaging is 40%. And then cell phone is not quite 25%, so that was the one I would do next probably. And then in person is 30%, about a third of the graph. About, not quite. And Facebook is 10%. The main thing here is not that they're perfectly drawn, but that you can tell by looking at the slice which part is more, which has what a higher percentage. Okay, which part has a greater percentage. Not necessarily, well, in this case we'll just say greater percentage. Are we okay on this? Let me give you a minute to copy. Are we there? And I've been saying scale, but I really meant key. You can make a key that says purple is text messaging, cell phone is, you know, that color, and so on. Okay, if you didn't want to write in it. All right. So just some like warnings about what to, you know, look for in terms of misleading graphs. Because bar graphs can be a little bit on the dull side, it's tempting to use pictographs instead of bar graphs. But you have to be careful with that, because if you notice, like for the none, we've got a little under 100, and for the Macintosh, we've got a little, like, I don't know, a little under 400, or somewhere between 300 and 400. Definitely to me, that doesn't look that, the Macintosh looks a lot larger than it actually is, because the area is so much bigger. And so you have to be careful, because when you use pictographs, if you're making a bigger area, then it seems bigger, like a bigger comparison than it actually is. Does that make sense? What are some other things that could be misleading in a graph? Yes, Dylan.
Don't know where the line is placed. Like, is it at the very top corner of the Macintosh, or is it?
Right. Yes, that's exactly right. Okay. And then what are other things we can do, not necessarily with this graph, but with any graph that would be misleading? Any ideas? Okay.
The width of the computer just seems larger than all others.
That's true. The width is messed up. Okay. Any other ideas?
Focus in on like certain numbers and not show the whole thing.
Okay, good. Yeah. One of the traps is to focus in on a shorter time span and not show the whole thing. One is to not start the y-axis at 0. Okay? So if you don't start the y, and you don't always have to start the y-axis at 0. Like if your data starts at 50, then you don't have to start at 0, but you do have to show that you didn't start at 0. So you should do, I'll show you, you should do a little squiggle line. You've seen it and probably are way early on. A little squiggle to show, hey, I'm not starting at 0. Okay? Another thing is, like you were saying, short, only showing small amounts of the graph, not the whole trend. Trying to think, not using a scale that's consistent. So they might go 5, 10, and then 12. Well, there's a problem with that, right? We want to be consistent, and we want those tick marks to be about the same distance apart. So 5, 10, 15, be consistent. And then also labeling can be misleading. If you don't put a label, we can't tell really what's happening. Okay, so you've got to label things. Okay, so some just warnings there for beware of the pictograph and watch those scales. All right, so now we're going to talk about analyzing data on with two-way tables. And so here we have a situation where we have our respondents, and we're asking them, are you in the environmental club or not? And then we're asking them, do you own a snowmobile? Do you rent a snowmobile? Or have you never ridden a snowmobile? Okay? Because we're wanting to see, hey, is the environmental club impact whether or not they would ride a snowmobile or own a one or rent one? Okay? And so we make a two-way table out of this, and a two-way table is a table of counts that summarizes data on the relationship between the two categorical variables for some group of individuals. And so that table might look something like this. We have, if we looked, and obviously there's a dot, dot, dot at the end, so they sit there and added up all the ones who said never and that were in the no group, okay? for owning for being in the environmental club, then we would get $445, and so on. Does that make sense? And one of the things I would encourage you to do, and I think I did it on your paper for you, is total those up. Give the total of no's, get the total of yeses, get the total of nevers, rents, and owns. So when I see a table like this, if there's not already totals there, I'll put them in right away. Okay? And then once we get all our totals done, then we can start analyzing the data in different ways. Everybody okay with that? All right. So the first thing we'll talk about are marginal relative frequencies, which gives the percent or proportion of individuals that have a specific value for one categorical variable. So the key here is marginal is only talking about one categorical variable. So how many were no's? How many were not in the environmental club? Well, there were 1221 out of the total 1526 that were not in the environmental club. Another marginal relative frequency would be the totals that were yeses. Okay, and so that would be 305 out of 1526. Are we seeing what we're doing there? What's another marginal relative frequency I could find?
How many people never use?
How many people never use a snowmobile? Okay, and so that would be the 657 out of the total. And then so on with the rent and with the snowmobile on. Does that make sense? So those are called marginal relative frequencies. They're just one category. And a marginal, in here it just says what I just said. It's just one category in a two-way table. Joint relative frequencies give you the percent or proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. So we're looking now at two categorical variables. And so a joint relative frequency helps answer questions involving both of the variables in a two-way table. So for example, what percent of people in the sample are environmental club members and, notice the and is outlined there, own snowmobiles. So it has to meet both criteria. So you look for the number that represents environmental club members and own snowmobiles. So how many are there?
16.
Okay, so snowmobile owners and environmental club, there's 16.
It's less than 1%.
And then it's out of, good, and it's out of 1526. And so it's rounded to about 1%. It's actually, yeah. All right? And so that's called the joint relative frequency. So with your neighbor real quick, answer the next question. What proportion of people in this sample are not environmental club members and never use snowmobiles? Okay, so if we look at the proportion that are not environmental club and never use snowmobiles, then we're talking about 445 that are in both categories, no and never used, out of the total. Everybody okay with that? Okay. So marginal and joint relative frequencies do not tell us much about the relationship between the two variables. So often we'll use something called conditional relative frequency, which gives the percent or proportion of individuals that have a specific value for one categorical variable among individuals who share the same value of another categorical variable, or the condition. And I'll show you what I mean by that. That actually sounds a lot more complicated than it is. So for instance, if I asked you what percent of environmental club members in the sample are snowmobile owners, well, who's my population? Who am I looking at here?
The 305.
Okay, I'm only looking at the 305, at the total number of environmental club members, right? So now I've got this condition on here that says, hey, let's look at the environmental club members, and of those people, how many are snowmobile owners? Do you see how that's different than the and statement that you just saw? Okay, so there's a condition here that we're looking at environmental club members. So we're only looking at the 305, and of those, there were 16 who were snowmobile owners. And so what you want to do is, it says the distribution of snowmobile use among environmental club members is called the conditional distribution. So we look at this distribution and we kind of helps us make graphs and help us decide if there's some sort of relationship. Okay, so we'll look at the distribution. And so to do that, we have to find all the yeses, if you will, the conditional probabilities for the yes category. So for the yes category, there were 212 out of 305 who never used the snowmobile. Then there were 77 out of 305 who rented, 16 out of 305 who owned. You might want to write those numbers down because we're about to use them somewhere on your paper. And then going on, oops, do I need to go back?
Actually, the right.
Is it down below? Oh, yeah, it's right there. All right, so I'm going to do that for the not environmental club members and for the environmental club members. So you might write those down real quick. Give you a second to do that. So we're going to use them to make graphs. Okay, so notice that we were able to do the same thing to get those conditional relative frequencies for both the non-environmental and the environmental, same process. All right, and then what we're going to do now is talk about how to compare those groups. So when you're comparing groups of different sizes, you have to make sure you're using the percentages. Because what people will do is there will be the environmental group and the non-environmental group, and instead of changing those to percents, they'll graph the raw numbers. Well, if you've got different numbers in each group, then that's a misleading graph, right? It's not just misleading, it's inaccurate. Okay? So when you're given an option, I would always use the relative frequencies. So go ahead and change it to percents. Even if they were of the like sizes, it's fine to change it to a relative percent. Okay? That's the safe thing to do. The other thing is to be sure in your language that you're using the proper language. So the words more club members never use snowmobiles is different than the words a greater percentage of club members, because more club members is referring to a count, right? But a greater percentage is being very specific. And so your wording is going to be important on that, because when you say more, then I'm like, okay, do they mean more as in count, or do they mean more as in percentage? So you've got to be specific. Okay? All right. So we're going to take this data and we're going to create a couple of types of graphs today. A side-by-side bar graph and a segmented bar graph. A side-by-side bar graph, just like it says, the categories are side-by-side for the no's, and then we'll have the yeses with their categories side-by-side. And a segmented bar graph is sort of like a stacked bar graph. It's exactly what it is. It's stacked. Have you seen those where the categories are stacked on top of each other? And if they're stacked on top of each other, what should they add up to be? 100%, okay? So, I'm going to show you both. Are we okay with this? All right. So, like I said, I wish I'd kept that chart up here because that would be easier. So, I'm going to, I think I'm going to go now. Here's the pretty one. I'm going to go now and do it on my own just so you can see how I approach it in the notes. Is that okay? Okay, so we're going to take those percentages that you just wrote down on the other page. Should have told you to write it on the last page. And we are going to graph those. So we can really quick write those in if you want. So if I were talking about the probability of never given no, so that was the never giving. So that's a way to write it. The condition is that they're not in the environmental club. And so you're saying the probability that they've never used a snowmobile given that they're not in the environmental club. So that's a conditional statement. Okay? And so that's that number you've already written down, the 445 out of the 1221. Remember, you just wrote that on the previous page. Everybody with me? Okay. And so that was, and I'm going to go to a couple decimal places so they add up to 100%. 36.45%. And then the probability that they were a renter, given that they were in the no group, and I'm not going to write the numbers, I'm just going to write out the percentages, 40.7%. And then the probability that they were an owner, given that they were in the no group, was 22.85%. Okay? So I'm going to do these, and I'm going to show you that part of the graph, and then I'm going to have you do the other part of the graph. Okay? So for the first part of the graph, first thing I'm going to do is go ahead and number from 0 to 100 on the left side on my y-axis. And so I'm going to start off and just try to do equal increments. So 10, 20, 30, 40, 50. Okay? And I'm sure yours is going to look better than mine. It doesn't take much. That's okay. And then I'm going to label this as percent, so it's clear I'm talking about percentages here. Or you can label it as relative frequency if you have more room. Either way. What does the word relative mean? Percent. Good. And then now I'm going to take that no category and write it right here. And then I'm going to use those percentages that I just found. So if we go down here, that never given no is 36.45%. So I'm going to go up to about what I think is 36.45%. And I can write write never in there, or I can color it or shade it a certain way and make a little key off to the side. I just wrote the word never. And then the next percentage was 25.25%. So, and notice it's not perfect, but it's good enough for you to tell what's going on. And I put rent for that. And then own was 22.85%. So it's a little bit. Was the rent supposed to be bigger? Was I looking at the wrong number?
Yeah.
Oh, I was looking at my other category. Sorry about that. Yeah, y'all stop me if you see me do that. I'll confuse the poor people watching the video. You gotta call me out on it. Yeah, that should have been 40.7%. Okay, so this is rent. And then my own group was the 22.85. Okay. And if you want, if your handwriting is as terrible as mine, you could put the percentages at the top to make it clear where you meant for those to be. Okay. And so I'm going to give you a couple minutes to work with your neighbors and do the rest of this graph. So this time I want you to add on to that the yeses. Okay? And then at the bottom here, let's be sure and label what our x-axis is, and that is environmental club. You can put membership if you wanted, but environmental club is probably good enough. All right, so I'll give you a minute to work on that. If you're watching the video, you might pause and try to finish this yourself. Okay, so there is the yeses. We have never at 69.5, rent at 25.25, and own at 5.25. And while we're taking a break, a student brought up that instead of writing just percent, we could say percent of snowmobile use, which is actually more accurate. I really like that idea of just being more accurate as you can be. So that was a great point. Thank you. All right. And so now we're going to do what's called a segmented bar graph. We're going to scale it up to 100%. Okay. So just like we did before, we'll label it pretty much the same way. It's just we're going to stack these bars on top of each other instead of side by side. Okay. So this is on the left is your side by side. On the right is going to be your segmented. All right, so let me do the percentages real quick. And same thing, percent. And then on this, we're going to make the scale the same way. We're going to do the nose first. So for the nose, I start off, and on the never for the nose, it was 36.45%. Now, I'm really horrible about stacking and making it look pretty. I know you can't even imagine that would be a problem for me. But we're gonna, I cheat here a little bit. I go ahead and go all the way up to 100 because I know that's where it's gonna end. And then straight back down. And then that was easier just to segment it from there. Okay? And I'll do the same thing for the yeses. I'll just make a little skeleton, if you will, of the graph. And then that way it's a little bit better looking graph. And so now I'm going to do it in the same order. So if I start with never on no's, I need to start with never on yeses. And so my nevers were 36.45, and I'm estimating that clearly. Okay, and so this is my never. And then what do you think I do next? Add the never and the rented. And so there were, never was 445 and renters was 497. So we add those together and divide by 1221. Or, add the percentages because you're going to get close. And so when you add those two, what do you come up to?
77.
What is it again?
Like 77 something.
Yeah, 77 something. Okay, so we're going to be up here close to 80, but not quite there. And that's going to be our renters category. And so then this has to be, okay, so far okay? See what we're doing? All right. Am I off on my height on this one? I am, aren't I?
You just always get 110%.
Right? It looked even at the time. Okay, is that better? All right, I'm standing at an angle, so. All right, so then on this one, same thing. I'm going to go never was 69.5%, so we're almost at 70. Okay, so I have a lot of room to write never here. And then if I add on my renters to the, so I'm going to add the 25.25 to the 69.5. And so when I do that, I get about 94.75 is what I showed here. And that is my rent group. And so then my own group is really small. Okay, so if I told you that I surveyed someone and they have never used a snowmobile, you might think, well, that might be that they're concerned about the environment. Based on this graph, you might say there's a higher probability that they're in the environmental club than that they're not. Would you agree with that? So that's called an association. So when we look at these graphs, we can kind of tell they're not independent. The two variables don't seem very independent of each other, right? Seems like we could kind of predict one based on another. Okay? And so that's called an association. So there is an association between two variables if knowing the value of one variable helps us predict the value of the other. Does that make sense? Okay? All right. Okay, so this is where we're at right now. The picture and the graphs here look a lot better than mine. They're much prettier. They have a nice little key and they've labeled it. And so once again, side-by-side segmented bar graph. All right, so we just talked about what is an association, and you can kind of see, even clearer with the colors like that, that it does appear that there might be an association. And what would it look like if you knew that there's just no way to tell which group they came from? Like, what would be the picture that would represent that maybe there's not an association?
They're pretty much the same.
Okay, they're pretty much the same, right? Their percentages for nevers were the same. Their percentages for rent and own were the same. If they're pretty much the same, then really there's not that much of an association, right? Okay, good. And so there's the no association picture. Good. All right, so association doesn't imply causation. Just because we're associated doesn't mean that one thing is causing another. It just means there's a relationship there. in order to prove causation, there's a whole nother lesson for that. Okay? So far today, what we've done today and what we're going to finish with today is that we've talked about making and interpreting bar graphs for categorical data and what makes some graphs misleading. We've talked about marginal, joint, and conditional relative frequencies on a two-way table. We've talked about how to compare those distributions and whether or not we can tell if possibly there's an association by just looking at the graphs. Does that make sense? All right, y'all did an awesome job. Have a great day.